Okay, Andy. Good morning, everyone. So the last class we started terminology of thread. Anyway, let me continue that. So according to multi-threading concept in Java, application means set of programs collected together to perform one defined action. We call it as application. Anyway, set of programs collected together to perform defined action. We call it as application. Process means the application under execution. We call it as a process. Task means set of process, part of process. We call it as a task. If you want to apply the definition of task in Java language, each program in application is a task. In that process, each servlet program or each server program, we call it as one task. Executing these multiple tasks simultaneously, we call it as multitasking. And we are performing thread-based multitasking. Executing multiple tasks simultaneously, we call it as thread-based multitasking, we say. So in the process of executing multiple tasks simultaneously, some part of task is executed. The part of task, we call it as what now? Thread. So here, the part of task, we call it as the thread. Now, thread other name is background and lightweight process. Background means a separate identification, not available. And lightweight means it consumes very less execution time. So the theory. And today, multi-threading, executing multiple threads simultaneously is known as multi-threading. Today I must run this program by demonstrating how to create and execute a thread. Make a heading star mark IMP 1. Creating and executing threads. Creating and executing threads. Creating and executing threads. So first we must analyze what we are going to do. See there. I am taking one application. I'll take one application for demo purpose. I'm taking one application. One application. Thread app 1. Roughly I'm taking. Like user app, we are saying thread app. Now user app has many programs, and thread app I am taking 2 programs. I'm taking for demo process, demo purpose. I'm taking 2 programs. One program is I'll take display 1. Program means class, class means program. Yes or no? Now this is display 2 for demo purpose. Now, like register and login, roughly we had display 1, display 2. This display 1, according to our threading terminology, that is one task. And this is one task. 2 tasks are available. This is one task 1. This is one task 2. All of it clear about our terminology, right? 2 programs in one application. This is task 1. This is task 2. Okay, right? Now look here. IDE Eclipse I'm taking. Right. Look here. I am taking one application. Click on File, New, Project. Thread application 1. So thread application 1 here. Right click on SRC, new, and package test I am taking. Always we take for execution MAccess. Now under test I am taking 2 programs. One program is display 1. One program is display 2. Display 2. Right. So 2 programs are ready. One is display 1, one is display 2. Now these 2 programs must be executed simultaneously. Yes or no? That's a target, right? Whenever you want to convert these programs into threads, whenever you want to convert these classes into threads, some process we have to follow. Then only they run like in threads. Thread means simultaneous. We have to execute display 1, display 2, display 1, display 2, you have to execute. So 2 programs simultaneously we must run. For that, what we have to do, sir? Make it step 1. The user defined classes must be implemented from java.lang.runnable interface. The user-defined classes must be implemented from java.lang.runnable interface. Runnable interface. Now, I want to see the structure of runnable. Structure of runnable. Coming from the library, no? Java.lang means coming from library. I want to see the structure of runnable. Right. Java P java.lang.runnable. Java.lang. Only one method is there, run. Write it and draw one box, runnable. One method is there. Right. Now look here. Whatever the classes available here, the classes must be implemented from runnable. That's a rule. Runnable one interface. Having one method known as run, where this is linked here. Implements. So these two are implements. You know the implementation rule, no? What is implementation rule? Sir, we have to construct the body for run. We have to construct the body for run. Sir. So now this user defined classes must take this run method. Take this run method and construct the body. Here I'll print 1 to 5. I will print it. The same way it has to take this run method. Void run method. It is printing from 101 to 105. One not one to 105. All have understood this? These are the rule only, no? Right. Any class implemented from interface, the class by terminology we say implementation class. The implementation class has to construct the body for abstract method. So here they are coming from built-in form. Runnable is a built-in, run is a built-in. We are writing the body. That body is nothing but there I written print 1 to 5, print 101, 101 to 105. Actual printing login logic, printing registration logic. There we write login logic and their registration logic. Actual that is. But here for roughly I'm taking printing 1 to 5, 101 to 105. Step 2. These user defined classes, these user defined implementation classes must construct body for abstract method run. Must construct body for abstract method run. Must construct body for abstract method run. Right. After this, now see there, we are constructing the body for abstract method run here in the diagram. Go for coding. So display implements from runnable. So public void run. Right. And this method is overriding method at the rate of override. Yes or no? Now? Should I give an annotation? No? Right. This is asking to check the method is overriding method or not. Suppose by mistake you written capital letter here, you written. Of course, you never write capital of names. Whenever you write capital letter, it says that this is non-overriding method. It says. Suppose if I remove this annotation, error will not come. Of course, it implements is there, no error will come. It's looking for override. So cross check my spelling whether it is overriding method or not. Cross check once again. So overriding or not. It's called at the rate of override. Now here printing for int. Some loop I am using now. Int I is equal to 1. I less than or equal to 5. I plus plus. This is end of loop. Here I am printing system dot out dot print ln. I am printing. Here I am printing the value. Means I am printing from task 1. I am printing. From task 1, I am printing the value. All have understood this? Right. After every printing, means I want to see the output bit slowly. Print 1. Before printing 2, some delay time should occur. For that, I am using one method known as thread.sleep. I am using thread.sleep. This method stops execution temporarily on time. Temporarily on time. Temporarily on time. But why error is coming means see there. This method is a static method of thread class. Java.lang.thread class. But this method signature will have throws keyword from the library. The method signature in the library will have throws keyword. Already you know the throws keyword, no? Any method having throws keyword, exception raised at method call. So exception raised at method call. Unhandled exception type, interrupted exception. To handle that exception, we write try here, catch, we take interrupted exception, IE dot print stack trace. Thread dot sleep stops execution temporarily on time. Now, what is this extra part means? To see the output bit slowly. Every output, it stops the time. 2000 milliseconds, it stops execution. So that you can see the output bit slowly. Clearly, you can see the threads are running or not. We are going to see it. The same process we are going to write. The same process we are going to construct in the display 2 here. Display 2 also implements from runnable. We have to construct the body for run. Only difference is here 101 to 105. This is task 2. Anyway, this is task 2. Like this, display 1 constructed, display 2 constructed. 2 rules we followed, implemented from runnable. Runnable has one run method. We constructed body for the run method, and the run method is having the logic. That's the concept. That is 2 steps. Then what, sir? Then step 3. Create objects for user defined implementation classes. Create objects for user defined implementation classes. Create objects for user defined implementation classes. You have to create object for display 1, you have to create object for display 2. Display 1 and display 2. Now, see there. I am creating object for display 1 and display 2. Demo thread 1 I am taking. Main class. Main class is always execution class. Import test dot star. Create object for user defined implementation classes. Display 1 D1 is equal to new display 1 object. Display 2 D2 is equal to new display 2. So creating object for user defined classes. All of you understood this? Now after creating objects now, if I call d1.run, suppose I'll say d1.run, I can call the method now. Right. d2.run, I'll call the method. Because in the d also run is there, d2 also run is there. See, I'm running the program. Run method from d1, see the output. Slowly coming or not now, small, slow. But running d1, then running d2. Sir, very simultaneous, sir. Simultaneous means you must write d1, d2, d1, d2. You must run now simultaneous. They are running uni-programming, one after the other. This is not threading, right? Whenever you want to do threading, we need one more method, start. One method is there, start method. That is a predefined method available from thread class. Predefined method available from thread class. We have to call that start method. We must ask the start method to call this run method. Then threading algorithm will run. Sir, how to call that start method? Whenever you want to call that start method, you have to create object for thread class. Thread T1 is equal to new thread. I have to create one thread object. Thread T2 is equal to new thread. You have to create object. Now T1 dot start, you have to call it. T2 dot start, you have to call it. These two methods to call it. But whenever I create object for threads, whenever I called T1 dot starts, thread will not run. Why, sir? Display objects and thread objects link not there, no? Yes or no? Na? There is no link between these objects and these objects link not there. When the link is there, start method will call the run method. Link not there. How to link it? References concept. Sir, T1 must hold T1. So pass T1 here. You know the concept, no? Yes or no? Na? Now T2 will hold T2. I am passing T2. Now link is established between the two objects. Now thread object holding reference of display object. The method of thread class can access the method of display class. That only references. Now start method will access run method. If start method accessing run method, what happens? See the output. Both are running or not now? Task 1, task 2, task 1, task 2, task 1, task 2, task 2, task 1. So simultaneously is running. Observe this point or not now? So two programs are running simultaneously. Now this is from display 1, display 2. Here 2 and 2 because it is running under Eclipse flavor. No. Eclipse is under OS. No. Some delay will come. Actually, in the versional, we run from server. No? Understood now? So the shifting time will be interrupted by your environments. Sometimes the programs will not run also. Threading program should be executed on server based, not console based. Only demo purpose we are running. At last, 2 you are executing simultaneously. Sir, display 1 method is running run. Display 2 is running simultaneously. So how it is running simultaneously means start method came no. Start method has one thread algorithm running. So how many steps you included now? Sir, 2 more steps included here. Make it. Step 4. Create object for java.lang.thread class, and while object creation pass the reference of user defined implementation class object as parameter. Create object for java.lang.thread class, and while object creation pass the reference of user defined implementation class object as a parameter. Class object as a parameter. While object creation, pass the reference of user defined implementation class object as a parameter. All have understood this paragraph, right? Okay. Now, step 5. execute run method using start method. Execute run method using start method. Execute run method using start method. Execute run method using start. So internally run method will call start method. So the program runs. If I rerun the program, sometimes the order will be changed also. Because internally algorithm will be running, it will take care. So this is the output. We got it. Now display 1.java, display 2.java, demo thread 1.java. This is one main class, and this is the output. So starting with 1, 2, task 1, task 2, task 1, task 2, task 1, task 2, task 1, task 2. Because of some delay in the environment, it starts 2 and 1. This output. Running 2 tasks. They're running 2 tasks simultaneously. They're only multitask. Running 2 tasks simultaneously. Some part only running. You're running only one part from task 1. Yes or no? Some part that is called thread. So you're running thread. Thread means what? Part of task 1. That's the meaning of multi-thread. Now, I want to see the diagram, sir. Execution flow. Execution flow of above program. Execution flow of above program. Execution flow of above program. Right. See there, how many class files available here? How many class files? Sir, 3 class files. Display 1 dot class file. Display 2 dot class file. Demo thread 1 dot class file. This is one main class. Right. One new thing is going to happen in the diagram. See there. Right. In JVM, we say method area, heap area, Java stack area. Like this, we write it. Do you remember? Right. Java stack area. Java stack area. In this Java stack area, one stack will be there. That is main stack. The terminology is main stack. This point I not revealed up to now. Daily I drawn the diagram of main stack only. Daily I drawn the diagram about main stack. But actually main stack will be there. Thread stacks also will be there. Java stack area speaks about main and thread stacks. Up to all chapters till now, only main stack will be running, thread stack not there. But Java stack area is collection of multiple stacks. That is main stack and thread stacks. Now main stack, where main method is loaded. Main stack means where main is loaded. Where that main is loaded. The main one, main we call it as main stack. There we are creating object. Display D1 is equal to new display. We are creating object. Display D1 is equal to new display. Whenever I create now, display D1 is equal to new display. Now one display object is created here. One display object created. The display object is holding one method known as run. In this run, we had a logic 1 to 5. So finally, D1 object created. Now we are creating object for D2. Display D2. Display D2. This display D2, one object created for display. Zero x2, where run method available. Run method available. 101 to 105. Where D2 object created here. After that, we are creating thread object. We are creating thread object. Whenever I create thread object, I am passing D1 as parameter. This is thread object. Now thread object is holding the reference of D1. So 0x1. Because T1 holding T1. Here, one run method we are imagining. We are imagining one run method. Here we had, T1 is equal to 0x33. Then we are creating object for T2. Holding D2. Zero x4. Where it is holding the reference of D2 means 0x22. where run method. Run a starter. I written wrongly here. Here start method no. Yes or no? Thread class will have start method, not run method. It is a start method coming from library. Like this, T2 created. Now here we are calling the methods. After object integrations completed, T1 dot start, we are calling the method. T1 dot start. So we are calling this T1 dot start. Actually, thread algorithms available in the start only. Without calling the start method, threads will not run. So I am calling the start method. T1 dot start. So whenever I call the start method now, whenever I call the start method, the start method will come here. Start method is a predefined method. The start method will do 3 works. Algorithm. The start method will ask the execution control, create one separate stack known as thread stack. Create one separate stack known as thread stack. So thread stack is created. Like main stack, separate memory created known as thread stack. Start method specify to create separate thread stack. That is step 1. Now the start method activate thread manager. We call it as thread scheduler. It activates one thread scheduler. Thread scheduler. This thread scheduler is like a thread manager, joins your execution engine. And the thread scheduler will use 2 algorithms. It has 2 algorithms. One is time slicing algorithm. One is priority based algorithm. These algorithms are built in. Now the thread scheduler is a thread manager. Start method activates thread manager. The thread manager joins execution engine. And the thread manager will have, when it is managing, it runs 2 algorithms. One time slice, one priority based. Sorry, it runs both algorithms, means no. It runs time slicing algorithm automatically. Whenever any priorities are there, then it runs priority based. Unless it runs time slice. So start method created thread stack, activated thread scheduler. Then the start method will say, I will look for run method now. Because I created stack, I called manager, stack is waiting, manager is waiting. So stack means separate memory waiting. To control that, one manager is waiting there. Now run method should come there. So start method will say that I'll go and call run method. How it calls now? In my object, for me one address is there. For me, one address is there. I'll take this address. I'll go to that address location, find the run method there. After finding the run method now, it will be loaded onto separate stack. I created one stack to you. Go and load there. Then run method will come here. Now from here, this run method will come and load onto this location. Finally, the run method came. This run method has a logic printing 1 to 5. Now, once the start method completes its execution, it's over. 3 steps only. Start method. Start method will destroy. When the start method destroys, control will go to execution engine. Execution engine control is there no. It asks the thread scheduler. You want to run a thread because you came and joined me. You are also supervisor only. Can I run thread? Thread scheduler will say no. Wait. According to your execution rule, when you destroy one method frame here, you must go to main. Go to main and check. Is there any thread calls available? Go and check. Now the control will come here. T1 dot start completed. No. So T2 dot start available. It gives information. I found one more start method calling from T2. Thread scheduler will say call it. Now we are calling T2 dot start. Thread execution not started. Still loading going on. So we are calling T2 dot start. We call it. We are calling the start method from T2. Start method from T2. Now I am calling T2 dot start. Whenever I call T2 dot start, now the start method will come for execution here. The start method will come for execution. Same no. When the start method came here, it asks, I want separate stack because I came no. I'm going to create one thread for you. Separate stack needed. It creates one more stack. Thread stack of T2. Now activates thread scheduler. Thread scheduler already there. Thread says I am available. So say it. Now record it. The start method says I created one stack. I'm going to load. Run there. Organize it. Thread scheduler yes. Now using this start method, control will go to this address and control will come to this object and finds the run method there and run method is included. Finally, run method loaded. When the run method came here now, start method work completed. Thread scheduler will say, go and check. Here, thread's not there, no? When the thread not there, it gives the information to thread scheduler. No threads are available there. Next what? Thread scheduler will say, I'll give one algorithm to you. Follow that algorithm. The algorithm is what now? Time slice. Now execution engine will follow instructions of thread scheduler manager and performs time slicing algorithm. Time slicing algorithm means some part, time slice with only some part here. I'll give some 2 milliseconds to you. You run this. After that, drop it. Go for the next one. Run here. Some part. Again, you come back and run some part. So some part here and some part here. All of understood this? Yes or no? Right. Now, how many threads are there? That many thread stacks will be created. All the threads will be running simultaneously. That is the concept. In real time also that only. Each web browser request will have one stack in the servers and they are running individually. So this is the flow of thread flavor. Up to now, you know only main stack. When the start method came, when the run method is there, when runnable is there, that is threading flavor. Now, whenever we use start method, separate stacks are coming and all that stacks are executed simultaneously. This is the concept behind your threading. All of it clear about the concept? So thread scheduler is a manager. Simply scheduling means organizing the meaning. So default algorithm is time slice. So theory. So each thread will have its own thread stack and executed simultaneously. Statement from this diagram. What you observed is from that diagram. Each thread will have its own. Each thread will have its own thread stack and all thread stacks are executed simultaneously. All have understood the concept, right? Okay. From Java 8 version onwards, we had Lambda. Everybody knows. This syntax is old syntax, 1.6 syntax. Recently, the threads are created by using lambdas. Let us convert the program into lambda. Make it creating threads using LAMPDA, lambda expressions. The method which is declared without method name is known as lambda. A run method without name. See there. Same program. Observe here. I'll take thread application 2. I'll take it. Thread application. So same, no? I'll copy it. Right. See there, all of you. Here, lambda expression must come, no? Yes or no? No. Right. Now, lambda expression here. Lambda expression means run method without name. Okay, right. Sir, display method replaced by runnable. Display method replaced by runnable. Yes or no? No. So here lambda expression come, that is different issue. Here to here, lambda expression should come. Lambda means run method without name. See there. I am going for display one. In display one, run method is there. No, this one is run method or not now. This is body, no. From to here body or not now. See, I'm cutting. The run method body I cut it or not now. Right. I'm writing here. One lambda. This is lambda. Run method without name. Remaining part I left here. This is lambda. Run method without name. The same way here. Display to runnable. Go for display to. This is run method. From here to here run method. Cut it. And paste opposite to runnable. This is lambda. Remove that. All are in a single program. No. This is one program. This is lambda expression and this is lambda expression. Advantage. 2 dot class files has been decreased. Display 1, display 2 not there now. Moreover, you know already. Lambda expression you can pass as parameter now. Right. See that I am passing lambda as parameter. Here D1 is there now. D1 means this one only, no. Can I pass this lambda as parameter? Yes or no? All right, I am cutting. Instead of D1, I am passing lambda. Total lambda as parameter to thread. Instead of D2, I am passing lambda. Total lambda as parameter. This is thread. Running or not? Okay, right. This is lambda. Generally, you can see the codes like this directly. This is actual look. It's a real-time code look. This is one thread and this is one thread. This is one thread. This is one thread. This is the actual look of your thread flower actually. See that? New thread from here to here, new thread. New thread means object created. Yes or no? That object dot start. All in a single line. Instead of writing that R1, T1, T1. For core Java only we write that codes. For you people only we write the codes. Third layer, Spring and web service. No variables you can see. Direct calling will be there. There are only services. Wherever you want, they'll create object and call it, they'll destroy it. It only destroys automatically, anonymous object. Object created, object don't have a name. Yes or no? Display T1 is equal to new display. T1 is the name. Here names are not there. So that objects are anonymous. They create, run, and destroy. They create, run, destroy. Services that only. In the real time, user started one service means they'll create a service, they'll run it, user log out, destroy it. Why? If anything, if you want to store it, they'll store it. Logic will be there, they'll store it. Beyond that, they will not hold the variables. Huge creating, loading onto variable, calling from variable, it takes time. Because they use this technique. So this is just I want anyway old code available in the first program, no fundamental code. Fundamental code means where student can understand the process. Because I written 1.5, 1.6 code that one. Old code. If you write old one only, student will understand because their differences are there. If I write directly this one, who will understand? Hope you are understanding, I think. Yes or no? If it is no also, yes only you must say. Right. This is just I want to show the look. I showed this. Say. Like this, if you want to create any threads, you can create it. I created 2 more threads or not? This is task 3. This is task 4. And this is from 201 to 205. 301. 3 tasks are running on 3 or 4? 4 tasks. 1, 2, 3, 4, 1, 2, 4, 3. Internal again shuffling will be there. At last they are running parallelly. 3 tasks. 1, 2, 3, 4. 1 2 4 3 1 2 3 4 1 2 3 4 1 2 4 3 running 4 tasks are not now. Here advantage is what? Coding advantage. Here only you can copy and come. No need to create separate subclasses. No. If we create separate subclasses, dot class files will be increased. No. Here dot class files not there because lambdas are there. Because of this reason, lambdas are popular. If I want to create 10 threads also I can create. Each user one thread in real time. So I can create 4 threads I am running now. Task 1, it's thread 1, thread 2. Task 1, just I am giving a name as task 1, task 2. All of you understood this? Right, okay. The flower, just I'll copy, right, make it. In this model, run method is declared as anonymous method, which means run method as LAMPDA lambda expression. Example, I took only one class, that is demo thread 2.java. So subclasses not available because they are all converted into. So completed. Now, hope you understood thread creation, everyone. Okay, right. Now, sorry, here I used thread scheduler. Make it FAQ. Define thread scheduler. Thread scheduler is a thread manager, which organizes threads for execution. Thread scheduler is a thread manager which organizes threads for execution based on the following algorithms. One is time slicing algorithm and priority based algorithm. Time slicing algorithm and priority based algorithm. Generally, thread scheduler will have two algorithms. It will use time slice always. Whenever the priority is there, it uses priority. Make it. In time slicing algorithm, all multiple threads are executed based on defined time slice. In time slicing algorithm, all multiple threads are executed based on defined time slice. Based on means all will get some time because T1, T2, T1, T2 running no. So some time they'll get it for execution. It's called time slice. Second point. Time slicing algorithm is default algorithm used by thread scheduler. Time slicing algorithm is default algorithm used by thread scheduler. Default means automatically uses that algorithm. Second algorithm is that specially activated when priority is there. In priority based algorithm, the threads are executed based on thread priorities. In priority based algorithm, the threads are executed based on thread priorities. In priority based algorithm, the threads are executed based on thread priorities. Threads will have priority. Based on that priority, execution happens. Sir, from where the priority comes means we only will give the priority. On what base you will give the priority means actually in the real time. When the user hit the server, the hitting time will be taken. Suppose two users requested server. Who came first, he is having highest priority. That's a concept. That priorities will be given. Sir, how many priorities are there? When 10 priorities will be given. 1, 2, 3, 4 up to 10. 1 to 10 priorities will be given. So 1 means highest priority. 10 means least priority. That's a concept. What? Right. Make it. Now, we use set priority method. We use set priority method to assign priorities for threads. We use set priority method to assign priorities for threads. General syntax is T1 dot set priority. T1 dot set priority. T1 dot set priority. Some 9 will take it. T1 is setted with the priority 9. That's a meaning actually. But the statement. The thread priorities. Priorities must be in between 1 to 10. One is the least priority. I am only getting it out here. 1 minute. Java P, Java dot lang dot thread. Here the words are there. Can you see this? Minimum priority, maximum priority. You can print them and check it. Static no? Thread dot. One means what now? Minimum. Minimum priority. One is the minimum means least priority. Thread dot normal priority. 5 will come. Here max priority 10 will come. 1, 5, 10. Can you see this? 1 is the least, 5 is the normal, 10 is the highest. Make it 1. Minimum priority. Minimum priority. 5, we say normal priority. Normal. 10 is the maximum priority. The following are the fields, FIELDS, fields from thread class. Thread class provides the standard fields from the library. They are static and final. Static means what? You have to access with class name. Final means what? One number is there. Whenever I print this, one number is coming. No? Right. Now, we use get priority method. We use get priority method to know the priority of threads. Syntax. If you want to know the priority, return type is int p is equal to t1 dot get priority. You can know the priority of threads. So 1 minute. Right. Look here. Multi-thread concept is not ended. I need one session for multi-thread. Okay, right. So tomorrow Sunday class is there. Sunday, 7:30 a.m. That is online. Right. Tomorrow one day you come in online tomorrow. 7:30 Sunday online. Right. If you don't want online, right, you have to come to the class on. If you don't want online, class will be on 23rd October. 23rd October, Sunday again. Thank you. Thank you. Understood? Right. Which one you want? 23rd or Sunday? Tomorrow 7:30, 2 hours class. Anyway, files concept on Sunday only. Anyway, right? The plan is like this. From now I am in leave up to 10th October. I am in vacation. From now, right? I am not available to institute for 10 days. Right? For you, it will not make any difference. Last batch, no. Right? Okay. I am not available for 10 days. Up to 10th, I am not available for the institute. So tomorrow I'll take the class by 7:30, the conclusion of multi-thread. Okay, right. So 7:30, 8:30, 9, 9:15, around 1.5 hour enough to conclude. After that, files concept will be there. Files concept only one session will be there. That one session, I'll allocate that session again on one Saturday. I'll call it. Okay, right. That Saturday information I'll give to you on Google Classroom. I'll give it at one session. If not, I'll mix that topic with another morning 7 a.m. batches. Then I'll mix it and say it. But 7 a.m. batch reached to collection already. That batch came very faster than you. Right? Okay. That one topic I'll mix with another one and say to you. So tomorrow, anyway, you are in the middle now. I'm conducting. Tomorrow I'll stop the car somewhere on the road and I'll say to you. Right. If my daughter don't disturb me. Right. So let me complete that. Okay. Right. Understood the statement, right? Tomorrow 7:30 the class is the continuation of multi-thread. What is pending in multi-thread means? Well, I'll give it. The same link. What your friends are joining. This link is there. Meeting ID is 8585-611-2316. I'll take it. 8585 8585 611 611 2316 2316. I'll post in your Google Classroom also. That one. And the password is 97222004. 97222004. 977. 977. This is ID and this is password. So tomorrow's class is thread synchronization one program and thread communication one program. So thread I'll close tomorrow and after that files I'll schedule it separately. One class I'll schedule it. If not, I'll give the information about other that's morning 7 a.m. That also is very complete when you will be busy with advance right. From Monday onwards, you attend advance class. So my advance level will time. Because already actually it was must come back and conduct your class but they given it in my batch observed already. So they schedule you by batch. They want to log me on your but not available. My name is there and that. But I'm not class not available for the batch. 2 days another faculty will take it. I'm going out to 10 12. I'll come back my qualification and I'll catch that batch. So after coming back, one Saturday is there. Followed by 15th one Saturday is there. I'll schedule 5 class Saturday offline and schedule. That information is given in the middle class. If I don't schedule on 15th, I'll schedule on 20. 19 one Saturday is there. That's Saturday. Means I'll schedule on Saturday class. Understood the plan. Okay, right. Take a break. We are meeting by tomorrow by 7:30 with the same link. So online 7:30.